Peter Yee. I'm one of the anesthesiology faculty at Duke University. I'm here with a colleague to go over a couple concepts regarding AI. Monica, if you want to introduce yourself.
Hi, I'm Monica. I'm going to be joining Duke next July, working in the biostatistics and bioinformatics department and the computer science department. And my research has been on AI for healthcare the past few years.
Great. I think Monica and I got connected just because of our joint interest in this area of AI in medicine. And we thought it would be very useful for people to just kind of have some basic understanding of what some of the terms are and what some examples might be. So we wanted to go through some of that today. So Monica, we could start off with just the basic definition of what AI is.
Yeah, so AI is a very general term, and I think it's often used culturally in ways that denote something that might be more impressive than what it necessarily has to be. But AI is just any agent that mimics a human. So that could be on a very simple, specific task, as opposed to, something that's like artificial general intelligence, which is kind of being talked about as, an AI that can, do any problem. But usually the field of AI is really focused on really small, specific problems. So, something as simple as, in a flash game, something that automatically plays tic-tac-toe with you could be considered definitionally an AI.
Okay. And then what would machine learning be?
Yeah, so machine learning is a subset of artificial intelligence, and all it says is now you're adding data to the picture. So instead of something where you might have, hard coded, if you see an X in one corner and then X in the other, you should go for the third corner or something that's a very human driven thing. When you are dealing with machine learning, you now have a lot of data to inform that decision. So an example of machine learning that I think people see on a really regular basis is the idea of spam filters. So spam filters can learn from, the past and when you said something is real versus spam, and learn that, things that might contain, you've won the lottery are likely to be spam most of the time, using different features like what's in the who's the email from, etc.
Okay. And so that would be a spam filter would be an example of machine learning. And then what would be deep learning?
Yeah, so deep learning is a subset of machine learning, and essentially, deep learning, instead of operating easily on a simple model, really adds these models with multiple layers of complexity. So every problem doesn't necessarily need deep learning. So potentially for something like a spam filter, maybe you can do pretty well with just kind of simple word level features. But let's say we were trying to do something like automatic person or object recognition. It's hard to sort of come up with you need kind of multiple hops where you first have to say like, are Monica's eyes brown? And then, all of these steps of reasoning that are really hard given all the backgrounds a person can be found in. So when you sort of need to do multiple hops of kind of reasoning, you kind of turn to deep learning models, which allow for a little more complexity in the task.
Okay. And then how does natural language processing kind of come into play with all this?
Yeah, so NLP or natural language processing is essentially, it can cross-cut all of these. So it's a subset of AI that deals with language. And you can do that without any data whatsoever, or you can do it in a machine learning or a deep learning approach. So similarly, computer vision is another subfield of AI that can kind of cross-cut, machine learning and deep learning as well. So it's sort of an independent access of what kind of data do you have? Is it text data or vision data? That's kind of separate from the actual underlying method.
Okay, great. So now that we have a basic understanding of what these terms mean, maybe we could talk a little bit more in depth about what some of these terms mean in the context of medicine.